Good day, everyone. I'm Jaya Muring. Our topic for today is all about sample search methods. Search algorithms are one of the most important areas of artificial intelligence. This topic will explain all about the search algorithms in AI. Problem solving agents. In artificial intelligence, search techniques are universal problem solving methods. Rational agents or problem solving agents in AI, ag search techniques mao ni ilang kasagarang gigamit ni strategies para masolbad ang usa ka problema ug to provide the best result. Problem solving agents are the goal-based agents and use a to-make representation. In this topic, we will learn various problem-solving search algorithms. Search algorithm terminologies. Search is a step-by-step procedure to solve a search problem in a given search space. A search problem consists of search space, start state, goal test. Search space represents a set of possible solution nga anaa sa system. Start state, it is state from which the agent starts searching. Goal test, it's a function that observes the current state and returns whether the goal state is achieved or not. Search tree. It is a tree representation of search problem. The root of the search tree is the root node which is corresponding to the initial state. Actions. It gives the description of all the available actions to the agent. Transition model. A description of what each action do. Path cost. It is a function which assigns a numeric cost to each path. Solution. It is an action sequence which leads from the start node to the goal node. And last is optimal solution. Is if a solution has the lowest cost or ubos ng solusyon among all the solutions. Following are the four essential properties of search algorithms to compare the efficiency of these algorithms. First is completeness. What is completeness? A search algorithm is said to be complete if it is guaranteed to return a solution if at least any solution exists for any random input. Next is optimality. Optimality if a solution found for an algorithm is guaranteed to be the best among all other solutions, then such a solution for is said to be an optimal solution. Time complexity, familiar naman jud mo ani siguro kay naman ni sa last year na to nga gihandulan ni Ma'am Alma, di ba? Time complexity is a measure of time for an algorithm to complete its task. And space complexity, it is the maximum storage space required at any point during the search, as the complexity of the problem. Types of search algorithms. Based on the search problems, we can classify the search algorithms into an informed or blind search, an informed search or heuristic search algorithms. What is uninformed search? The uninformed search does not contain any domain knowledge such as closeness, the location of the goal. It operates in a brute force way as it only includes information about how to traverse the tree and how to identify leaf and goal nodes. Uninformed search applies a way in which search tree is searched without any information about the search space like initial state operators and test for the goal. So, it is also called blind search. It examines each node of the tree until it achieves the goal node. Sa informed search, maghatag lang ko og brief kanang description kay i-discuss man gud ni siya sa next group. Informed search algorithm use domain knowledge. In an informed search, problem information is available which can guide the search. Informed search strategies can find solution more efficiently than an informed search strategy. Following are the various types of uninformed search algorithms. Ag breadth first search og deep first search, maghatag lang ko og kanang brief kanang description kay na-discuss naman gud ni sa previous groups. Ag breadth first search is the most common search strategies for traversing a tree or graph. Ag naka-advantage ani niya kay it will provide a solution if any solution exists, and if there are more than one solution for a given problem, the BFS will provide the minimal solution which requires the least number of steps. But naa sad ni siya disadvantage. Ang disadvantage sa BFS, it requires a lot of memory since each level of the tree must be saved into memory to expand the next level. BFS needs lots of time if the solution is far away from the root node. Next is depth first search. Depth first search is a recursive algorithm for traversing a tree or graph data structures. The advantage of DFS requires a very less memory as it only needs to store a stack of the nodes on the path from root node to the current node, and it takes less time to reach to the goal node than BFS algorithms. Og a disadvantage of DFS, there is the possibility that many states keep recurring and there is no guarantee of finding the solution. DFS algorithm goes for deep down searching and sometimes it may go to the infinite loop.
The third various types of uninformed search algorithm is deep limited search algorithm. A deep limited search algorithm is similar to deep first search, with a predetermined limit. Deep limited search can solve the drawback of the infinite path in the deep first search. A deep limited search can be transmitted with two conditions of failure. First is standard failure value and cutoff failure value. Standard failure value, it indicates that problem does not have any solution. And cutoff failure value, it defines no solution for the problem within the given depth limit. There's the advantage and disadvantage of deep limited search. Advantage of deep limited search is memory efficient, and the disadvantage is incompleteness. It may not be optimal if the problem has more than one solution. So, we're going to learn how the deep limited search works. Deep limited search is just a combination of DFS. That means we're going to see the DFS applications here, but there will be some limitation of the level. Muna siya ang example sa deep limited search. Ang deep limited search kay na ay level 0, level 1, level 2, level 3. Ang limit anhi nga depth is nara sa level 2. Then ang goal node is J, si J. So kani is similar naman sa DFS. So mag-start ni siya sa S. Root node nga S. So, ang root node nga S, i-visit ni dyan na ang A down to C. Then, C going to D. So, anong wa natin ni Ari sa E, kay ang limit is sinara sa level 2. Dili na ta pwede mo Ari sa E, kay nag-crossing the limit naman ta. So, balik ta dahil sa D. Then, kaning A is na-visit naman ni siya. Muari na ta sa B. Mu-backtracking na ta sa B. Then, going to I. Then, sa J. So, sa J is muna siya ang goal node. Na-reach na nato ang goal node na J na naa sa level 2. The fourth various types of uninformed search algorithm is uniform cost search algorithm. Uniform search algorithm is a searching algorithm used for traversing a weighted tree or graph. This algorithm comes into a play when a different cost is available for each edge. The primary goal of the uniform cost is search to find a path to the goal node, which has the lowest cumulative cost. Uniform cost is equivalent to VFS algorithm if the path cost of all the edge is the same. And there's an advantage and disadvantage of uniform cost. The advantage of uniform cost is optimal because at the very state, the path with the least cost is chosen. Disadvantage: it does not care about the number of steps involved in searching and only concerned about the path cost, due to which their algorithm may be stuck in infinite loop. Stuck sila sa infinite loop. The thing here is example of uniform cost search. We have to take this as a minimum. It is a lowest accumulation cost that we need to be sent. So, first start with the root node. From root node, we'll take 1 and 4. Obviously, it goes 1 because 1 is smaller than 4. Then, 3 and 2. And the selected path is 2 because 2 is smaller than 3. So, when we come into the D, is 3. So, it goes, we reach the goal node G. And the fifth various types is iterative deepening deep first search. The iterative deepening algorithm is a combination of DFS and VFS algorithms. This search algorithm finds out the best deep limit and does it by gradually increasing the limit until a goal is found. So this algorithm performs the deep first search up to a certain deep limit, and it keeps increasing the deep limit after each iteration until the goal node is found. Then mao ni sa ang example sa iterative deepening deep first search. Then mag-increase ang limit anhi until the goal is found. So, ang ijahang iteration is, ijahang first iteration is A sa root node. Then, the second iteration niya is A, B, C. Ang third iteration niya is A, B, D, E, C, F, o J, G. Then, the fourth iteration niya is A, B, D, H, I, E, C, F, K, ug G. So, mag-stop na ta sa fourth iteration kay nakita naman ang goal node nga G. The sixth various types is bidirectional search algorithm. Bidirectional search algorithm, it runs two simultaneous searches. One from initial state called as forward search, and other from goal node called as backward search to find the goal node. Bidirectional search replaces one single search graph with two small subgraphs, in which one starts with a search from an initial vertex and other starts from the goal vertex. The search stops when these two graphs intersect each other. Bidirectional search can use search techniques such as VFS, DFS, and DLS. And the advantages of bidirectional is the search is fast and requires the less memory. And the disadvantage is implementation of bidirectional search tree is difficult. In bidirectional search, one should know the goal state in advance. So in the example below, search tree bidirectional search algorithm applied. So mo sila na applied. This algorithm divides one graph tree into two subgraphs. It starts traversing in node 1 in the forward direction and starts from the goal node 16 in the backward direction. So kani goal node mo backward ari sa intersection, then si root node move forward ari sa intersection. The algorithm terminates at the node 9 where the two searches are met. So, ari sila magtagbo sa 9, sa node 9. That's all.